Right. So basically, if you think of objects, think of them as objects. Pretty much you've got a data type, you've got an object of the data type. And if you're thinking, okay, if I'm creating my own data type, or if I'm creating objects and I can sort of relate it to people, I said mostly when humans create things, we try to mimic the natural world as much as possible. So basically, if maybe I've got, we've already talked about having a child as well, a child of an object, for example, or a child of a class. So I have a class. That class can have its public members. Okay, that's great. It's got its private members, which can be accessed by other members of that particular class, or these members can be variables, or it can be methods. And then it's got its protected, it's got its protected members, but the protected members can be accessed through the class itself or by children of the class. We call the child of the class a derived class, right? It's derived from that particular class. Good. So we sort of given the concept of the way that things work with people like family. So basically, if I own a house, or if Dustin owns a house, let's turn it around, and I'm Dustin's son, and then maybe Dustin says when he buys another house, I can inherit that particular house, the first house he has, then great. I didn't have to pay for it. I don't have to find out how much the house costs. I can try, but I don't really have to find out because it's just giving me, right? So I don't have to think about how to make the money for it. I just get access to it because Destin has it. So it's sort of the same concept of inheritance that we are transferring to classes. By the way, remember, if it is protected, it's going to the child. If it is private, it can also go to the friend. Yeah? So we want to talk about inheritance, and at some point, I'll be pointing you to operator overloading. You've got function in the folder for week 11 that gives you a bit about overloading. And then we've got polymorphism. To morph something is to mold it into one form. Poly means several, so you're thinking about several forms, yeah? But you can look into it once you actually, after you do your revision or when you start your revision. Right, inheritance. So this is one of the most important concepts of object-oriented programming. And also the inheritance allows us to define a class in terms of another class. Basically, we just get benefit from the members or functions of what the other class already have. Basically, which makes it easier to create. It makes it, I think that's the key significance. It makes it easier to create and maintain applications. Right. Also, it gives us the opportunity to reuse code. The whole concept of classes is code reusability anyway. And of course, encapsulation or hiding content. So basically to reuse code functionality, and then also for fast implementation. So we don't need to implement stuff again. I've seen something pop up in the chat window. I'm going to add it. Okay, so it's just Raj coming back. Raj, welcome back. So basically, when we are creating a class, instead of writing all the codes, so instead of me working hard to build another house and everything, this thing just says, here's a house, you can use it for free. Good. So basically, instead of writing completely new data members or member functions, we can make use of member functions that has already been created to a particular class for the new one by using the inheritance process, right? So basically, the existing class is called the base class. So the parent class is what? The base class. And the new one or the child is called the derived class. Similar concept to what we've done before. Right. So looking at base class and derived class, basically saying that so the class can be derived from more than one class. So if you think about it, a child can have more than one parent. Yeah. So if, I don't know, if I've got my dad, I can inherit stuff from my dad. I can inherit stuff from my mom. Pretty much, as long as they give me access to it, right? So, and of course, I can have, which means I can have grandparents and all those kind of things. So a similar concept, like a family tree. So basically, how do we say banana in this particular language, right? As always. So to define the derived class, we use the class derivation list specifier by specifying the base class, really. So let's look at something that we did earlier. I mean, I would just go for underscore for this because I'll just go for underscore for this because in C++, the naming should be underscore, not necessarily minus. So, but then it's just to make sense, just to get us, help us understand the syntax. So we've got a class, we've got a derived class, which is the name of the child. Then we've got the specifier there, and then we have, or as a specifier, then we have this particular access specifier can be public, private, or protected. Okay, that will just decide what we are inheriting from that particular class, how we are inheriting it. So how we are inheriting what we are inheriting from the base class. Okay, so the base class is the parent class. So base class here is the class that is has the house that will be accessed by the child. See it that way. So pretty much the access specifier can be public, private, and or protected, and the base class is the parent class or previously named class. Okay, so basically, if we don't specify this, they're automatically inherited as private. Yeah, remember, private means that it needs to be accessed within the class or within the scope of the particular class. So you need members of that same class or member functions of that class as well. Can I continue? One person say yes, we continue. Good.
Yes.
Just spill coffee over myself. So let's try this out. Public. Okay. Yeah, we can try it out. It's only to make things easy that I'm just using code from here, but again, let's do some indentation to make it a bit readable. Okay, so we've got two classes, right? First class called vehicle, and then the second class called what? Car, right? So the vehicle has it's got a variable called Ford, and then it's got a function called what? Honk, which is toot toot, right? So inside of it, through the vehicle, we can have the brand, we can have a Ford, and then the Ford can actually honk as it's got a method that allows it to honk. Then we have another class, which is car. So we want the car to be a child of vehicle. We want it to be a derived class of the base class vehicle. So to make it a derived class, we just use the column, not double column, okay? Just the column, and then we want to specify the way that we are assessing the members as public, which means that these members will be assessed as public or will be inherited as public, okay? So after we create the derived class car, inside the derived class has its own public member function called the string model, or called, it's got its own member variable called model of type string. And in the model of this particular car is what? Mustang. What this means is that we have the car with a variable called Mustang, and again, it's also inherited a variable called Ford, and also it's inherited a method called honk. So we go into our main function, and we create an object of car. This object of car called my car can honk, even though inside car, there is no member function called honk. But that's because we've already written code, a function called honk, which has been inherited through the vehicle class. So again, we can make use of brand of my car, which is type car, but it inherited the brand from Ford. From the vehicle. Then again, we can also print out the model. So if I run it, hopefully no errors. A bit of errors. Let me just add it. And run again. Then we've got T2, and then we notice that it's inherited, the honk is inherited the Ford, and it has its own Mustang as well. Does it make sense so far?
Sir, can you explain vehicle?
Yeah.
Then we declare it as a public. We have created a string brand Ford. We have created a function void honk here. Then I didn't understand derived class here.
Yeah. So what does this do? Line 13.
Yes, sir. Explain me, please.
Yeah. What are we doing in line 13? What I have highlighted, what does it do?
Yeah, calling our classes public vehicle. This one, line 5.
Did you understand what we explained here? Should I give you a minute to absorb what's on the slide?
Yes, sir. Yes.
You see, I'll give you a minute to absorb what's on the slide, and then you explain to me what is happening on that particular line. Okay, so when you're ready, you tell me and I go back.
Sir, we have created base class.
Good. So the base class is the parent class. The derived class is the child class. Yeah.
Okay, sir.
The children inherit from their parents. So in this particular case, whatever is within the parent will be inherited by the derived class of it. Okay. Yeah. Derived is child
Yes,
class.
sir.
So this is just a syntax. So we are creating a child class or derived class of this particular base class or parent class. The access specifier is how we want to inherit the contents of the parent. So if I go back to this particular line, this is what car is what? Is car derived, or let me ask it this way, is car parent or child class? Would you say, if I put car here, is car parent or child class? Are you still with me, Isha?
Yes, sir. Yes.
So it's
Sorry.
car, sorry?
Child class, child.
Okay. So child, the key word for it is what? The derived class. Is vehicle parent or child class? It's just like Lego, we plug in. So the vehicle is here, it's vehicle, child, or parent class.
Parent.
Right. So again, that's the derived class, right? That's the base class. So pretty much that's all we're doing at this point. We're just creating another class, and the class has its own members in addition to the members of whoever is inheriting from. That's all the code is about. Yeah.
Yes, sir.
So it's like we are giving this car the key to the members of vehicle. So he says, you're more than welcome to use these members as long as you can access them within the scope with which we, it's been specified. Perfect. Good. So we carry on. So access control and inheritance. So basically, we're just looking at how we access our inheritance and things, right? Let me make sure, am I still recording? I hope I'm still recording. Good, I am. So a derived class can access all the non-private members, okay? So remember earlier, they could access protected. Private members can be accessed by the friends or members of the same class, right? So derived class actually can access the protected members and public members, right? So as far as if something is defined as private, it cannot be accessed by the derived class, or it cannot be accessed by the children. So think of it as a, I don't know, safe deposit box. That's a big thing. Think of it as the over 18 stuff. I don't know how else to say it, right? Yeah. So basically, things you decide, yeah, that's private to you, but still you decide to share with your friends, but not with your kids or brothers and sisters or something like that. Okay. So which means that the base class members, the base class being the parent class, members that should not be accessible by the member functions of the derived class should be declared private, right? So basically, if you don't want the kids to have access to it, then just say put in a safe deposit box, label it over 18 or something, so you do not have access to that. Anyway, I think it makes sense to me. I hope it makes sense to you as well. But pretty much, if you have a base class, which is a parent class, and you don't want the derived class, which is the children class, or the kid class or the child class is the right way to have access to certain members, just define them as private. But remember, the friends can also access that one. And those members of that particular class can also have access to it. Good. So derived class inherits all base member methods, and I would say the non-private member methods with the following exceptions. Okay, it cannot inherit the constructor, which we have talked about. It cannot inherit the destructors, neither can it copy the constructors of the base class, because pretty much by default part of it. Yeah. Raman asked the question about constructors and destructors, which we clarified earlier. So it cannot access overloaded operators of the base class. So overloading simply something like if we have 1 + 2 is equal to 5, and you overload the plus operator to mean something else, you can actually, if you think of string, the plus is like overloading. You can have Michael plus Ajuman, and then the plus does not necessarily mean adding two things, but it means concatenation. So if you redefine certain keywords, you are kind of overloading those keywords. And C++ allow you to overload some of its operators. Okay. Yeah. So the friend functions, we cannot also inherit the friend functions because, of course, the friend functions can access the private members. So it's just a few ground rules for us. So good, type of inheritance. I'll have to make this big as we go along. So when deriving a class from the base class, that's when creating a child of a parent. The base class may be inherited through, we have highlighted the access specifiers, or member, the access specifies how we access these things. Area, which is private protected or private, private protected or public type of inheritance. So pretty much we hardly use these two, the private or protected inheritance, but the public one is common, depends. But again, we just need to know how these work so we can decide, or you can decide later on when you're writing your fancy codes. Hopefully you can see it much better now. Hopefully it's not too big. But in terms of the rules for the inheritance, so we've got a private, public, sorry, and then we've got protected, and then we've got private, right? So the public, basically, when you inherit the public, we use the public to specify the public members of the base class, that's the public members of the parent class, will become public to the derived class. And also the protected members will become protected. It's kind of saying that whatever you have in the parent, keep the access exactly the same way, right? Remember, it cannot inherit what is private members. So it has got access to only the public and the protected. So let's say Dustin decides that he's giving up, let's say, his YouTube account, for example. And the YouTube for me to look after. He's moving to a new YouTube channel, sorry. So he's giving up one YouTube channel for me to look after. He's giving up his new YouTube channel for another one, for example. And on that YouTube channel, he's got some videos he's made public, and he's got some videos he's made unlisted. The unlisted ones only he could see, but now I can see it too. So I say, whatever was public, I keep it public. Whatever was unlisted, I keep it unlisted. I just keep the same format. So that's what the public keyword does. So whatever was public remains public. Whatever was protected remains protected. Good. Then we've got the protected inheritance, right? So basically, if he hands it over to me, that's if we specify the base class as protected when we are doing when we are creating the child class, and we use the protected member as a specifier, then that means that the public one, we are also converting to protected members, and we are keeping the protected members protected. So Destin says, I give you the channel. I say, okay, good. But Destin, maybe all your public videos, I'm going to make unlisted, which means whichever was unlisted before also remains unlisted. Yeah, so I'm so overprotective that whatever I've inherited from him, I'm keeping very well protected. Yeah, then we've got the private one as well. So again, if we go to when we specify at the point where we are creating the child of this parent class or base class, we specify them as private, we specify them as private, then it means that both the public and protected members are being converted to private in the derived class, which means I have a derived class, I'm converting it to private members, and these private members can be accessed by what, friends? Makes sense so far? It's just a matter of familiarization, using analogies to help you remember, and the rest, typing the code itself. Let's see if this code is complete. Let's try it out. We're going to get through some things, but yeah, let's talk it through and then we try it out. So remember, we have our parents, our grandparents, our great-grandparents. So my parents can inherit stuff from my grandparents, and I can inherit stuff from my parents. So if it is a gene pool, so my grandparents pass some genes to my parents, and then my parents also pass some of their genes to me. So there are some things I inherit from my grandparents through my parents. Makes sense? Yeah. Makes sense to me though. Right, good. So we've got a multi-level inheritance where a class can also be derived from one class and which already derived from another. Basically, parents can give birth to children as well and great grandchildren, which means basically, let's look at this code. Let's look at the code first to see how it behaves. Hopefully the code is complete. Right. So let's walk through the code. So we've got base class, parent class. We've got the derived class, which is the child class. And then we've got the main function. So these are sort of the three key functions in there. So two that are not necessarily functions, our own data type, the class. If we look at the parent class, we've got a member function, which is just simply called my function. And inside my function, we just say some content in parent class. So just to let us know we are inside the parent class, okay? Then we've got a child class. At this point, we say we have a class keyword following the name of the class name we are creating to show that, and we use the column to show that what is a child of this particular class. Now, how are we inheriting the content? We are assessing them as public. An example of the YouTube thing, which means all the videos which are publicly available, we're keeping them public. All the videos which are unlisted, we're keeping them unlisted, right? So we are keeping the protected ones protected, right? So we say inside here, we want to say we go to, well, we have inside the inside the child class, we also want to create what? A grandchild, right? So we say, let me have this. Let me set it up properly, not inside the child class. So we've closed that there. And we create another class called the grandchild. And the grandchild, we are inheriting something at this point. And who are we inheriting from? The child class. Yeah. So we are also assessing the members publicly. So pretty much public remain public, protected remains protected. So through this grandchild, we can get access to the child, and then through the child, we can get access to this particular gene. Grandchild. Yes, will be inside the mind grandchild. So if we say inside the mind grandchild, we create an object of mind grandchild only. We've not created an object of the child or the parent. Yeah. So inside the mind, from mind grandchild or my object of the grandchild, we want to jump straight away to pull out the gene of the grandparent. Yeah. So if we run it, we have something from the parent class. So pretty much we jump into from grandchild to parent to grandparent, and then we got that gene out to print out. Does it make sense to us? Yes? Online?
Yes.
Brilliant.
Yes.
Good. Nearly there. So we have multiple inheritance. That sort of brings us to the concept of inheriting something from the father or inheriting something from the mother. And then of course, the father can also inherit something from the grandfather, and then also from the grandmother from the father's side. And the mother can also inherit something from the grandmother, and the mother from the, I'm even confusing the grand. It's a long family tree thing. Everybody can inherit from people that they are directly linked with. Right. So if we look, just walk through a bit of the notes on the side. So a class can also be derived from more than one base class. Basically, you can get some stuff from more than one parent using the comma separated. It's quite similar to the way that we write int x, comma y, comma, it's just similar. But in this particular case, we are using, so this is like the class, and then we're saying we inheriting from this, we inheriting from that, we inheriting on and so forth. Yeah. So it's just a comma separator. So it's pretty much, let me make it big so we can see it. We've got a class, the child class, the first parent, second parent, and you can create more. I don't know, friends of the parents who can dash some things out, right? Okay, so where access is one of basically these three, public, protected, or private, which is just the same way that we access it, pretty much the same way. And will be given for every base class, and they will be separated by the comma. So basically, just specify the way that we access all of them. So easier if we try the code. So let's try code. Oh. So inside the code, we've got my class with the parent class. Then we've got another class with also another parent, because they are defined in the standard normal way. And we have this child class here. So we're creating a child class, and we know it's a child class by this column. And the child class is actually inheriting publicly from the first class, the first parent, my class, and then also inheriting from the other class as well. So it both the same way is inheriting inherited the first one publicly for the my class or the first parent, and again it's inheriting publicly from this other class. So it's got the two parents there, and inside the class basically pretty much does nothing. So it's got, in terms of content, we've got my function from the parent, and it prints out contents of the parent class. And then we've got, again, my other function from the other parent, and it prints out another class. So it's inherited these two sets of genes. I would say that way. I'm just making the gene part up, really. So it's got these two set of genes that is inherited, and through the child, we can have access to it. So we just say in the main function, first of all, we have the child class, we have an object of the child class, and we go into that object and we print out the gene, or we get access to the gene that is inherited from the first parent, and then also we get access to the gene that is inherited from the other parent. The genes are easier to understand, but basically it's just a function is inherited from the first parent, and again, a member function is inherited from the other parent. And these parents are what? Base classes. The derived class is what? The child class. Okay, so we run it. Where does the error come from? Line 9. What did we miss in line 9? Let's see. This is this one. If somebody sees something I'm missing, let me know. Expected that at the end of input. Anybody knows what I'm missing? Huh. Let's debug all together. Hopefully, well, the error, then maybe fine. Yeah, that sorts it out, right? Okay, so shall we end line here, so at least we know where we are? So yeah, so pretty much when we create the first, when we call the first gene, or basically the first inheritance we have, it worked from the parent,